Calculus, video 24, the product rule. Okay, so far we have the power rule, which we like a lot. We have the constant rule. We have the rule for taking the derivative of e to the x. We are now going to enter into learning 3 more rules. And these rules allow us to take derivatives of more complex things. However, that means that they themselves are more complex than, say, the power rule or the derivative of e to the x, or derivative of constant. The first one we'll have is called the product rule. So the product rule, we're going to use that anytime we want to take the derivative of 2 functions multiplied together. Hence why it's called the product rule. Product means multiplying. If you see 2 functions like f of x and g of x here, f of x is being multiplied by g of x, f of x times g of x, 2 functions multiplied together. I want the derivative of that whole thing. We have what's called the product rule. So if you're picturing this, something like h of x is equal to 3x squared times e to the x. Now, when I look at 3x squared times e to the x, I see 2 functions. I see the function 3x squared and e to the x, 2 functions. You could take that constant 3, right, and you could put it with either one, but you don't put it with both. It's not 3x squared and 3e to the x. Or you kind of think of that constant as just kind of being out there, right, and then the derivative of everything else. Either way, but I think it's fine just to go ahead and stick it with one of the functions like x squared and make it 3x squared as the first function. So you might be thinking, well, is the derivative of f times g of x, is it just f prime of x times g prime of x? And while that would be awesome, it is not. It doesn't work that way. I can show you that it does not work that way. Let's try, for example, why it is not just f prime of x times g prime of x. Let's take 2 functions, such as 3x times x squared. All right, so let's say h of x is equal to 3x times x squared. Now, forget the product rule for a second. We know how to do this already. If you had this problem before today, you would say, oh, I know how to do that. I'm just going to multiply 3x times x squared. That's going to be 3x cubed. Then I'm going to take the power rule, bring the 3 down, call that 27x squared. And I'll be done. And yes, you absolutely could do that. But for this example, I want to show you with something that we already know the answer to show you that f prime of x times g prime of x does not work when you're talking about taking the derivative of 2 things multiplied. All right, so here goes. If instead of going ahead and multiplying 3x times x squared to get 3x cubed, we kept that as 2 separate functions. Whatever we take the derivative, whatever rule we're using here, had better still end up with an answer of 27x squared, right? Because the derivative of h of x is 27x squared. And if we try this, if we try to call this like the f function, the 3x, call the x squared the g function. If we try just to do f prime of x times g prime of x, we will see that we do not get the same thing. The derivative of 3x is 3. The derivative of x squared is 2x. And when I multiply that together, that is 6x. And 6x and 27x squared are definitely not the same thing. Hence, h prime of x, well, let me say this. Hence, for h of x equaling 2 functions multiplied together, in this case 3x times x squared, the derivative of h of x is not f prime of x f prime of x g prime of x. It doesn't work. We got 6x when we should have gotten 27x squared. So, note, if we have 2 functions multiplied together, their derivative, you cannot simply take the derivative of each one and multiply them together. For the product of 2 functions, The derivative is not the derivative of the first times the derivative of the second. Of the first function times the derivative of the second function. Okay, so we've established what it is not. For a product of two functions, like f of x times g of x, the overall derivative is not the derivative of the first function times the derivative of the second function. It doesn't work. It's not f prime of x times g prime of x. So the question is, well, what is it? Okay, here's what the product rule says. Product rule says that if you have a function like h of x, which happens to be the product of two functions, f of x times g of x, the derivative of h of x, h prime of x, is equal to the derivative of the first function, so f prime of x, times the second function, just times g of x, whatever g of x is without the derivative, plus the first function, f of x, not the derivative, but just the first function itself, times the derivative of the second function. That is the product rule. We will use that over and over and over again in this class, in Calc 2, Calc 3 as we move on. So we need to know this. This is added to the list of all the derivative rules we need to know. Power rule, constant rule, the derivative of e to the x, and now product rule. Let's go back to our kind of simple example up here of h of x is equal to 3x times x squared, where we know the derivative had better be 27x squared, because we were able to multiply it and then just do the power rule. So h of x equals 3x times x squared. H of x equals 3x times x squared. So the 3x here is acting like my f function, the x squared is acting like my g function. H prime of x then is the derivative of my first function, the derivative of f, the derivative of 3x is 3, but not times g prime, but just times g itself, x squared. We leave g all alone. Plus, then it's f of x. We leave f all by itself, so just 3x, times the derivative of g of x. Sorry. The derivative of g of x is 2x. And we have here 3x squared plus 6x squared gives me 9x squared. And what you're saying, well, what did I do wrong earlier? Because those should be the same. Did I mess something up? I did. I said 3 times 3 was 27. My apologies. What is 3 times 3? Of course, it's 9. Hopefully you caught that earlier. 3 times 3 is 9. And then x squared. H prime of x is 9x squared. Sorry about that. We got 6x when we tried f prime times g prime. That's still not right. It's still not 9x squared. But when we did the product rule, we did f prime times g plus f times g prime. We noticed that we got 3x squared plus 6x squared, which is 9x squared, which is the actual same thing as h prime of x. The product rule works. A couple of things. Note that multiplication is commutative. That means I've done f prime of x times g of x, but if you did g of x times f prime of x, that's okay. Right? You can switch the order. Same thing in that second term. I did f times g prime, but if you did g prime times f, that also works. All right, let's try to prove it. So we kind of showed that it works, but let's actually prove the product rule. Proof of the product rule. All right, so we are trying to prove that the derivative of two functions, f of x times g of x, is equal to f prime of x, g of x, plus f of x, g prime of x. And we just have to know this. This should be memorized soon. Okay, in order to make a proof of a derivative, right, we're doing the derivative of two functions multiplied, you almost always go back to the limit definition of the derivative. Let's call this h of x, right, h of x being f of x times g of x. So we would say that the derivative of h of x is the limit as h. I now wish I hadn't put h there. Let's do a quite little substitution there. Call that capital H of x. I don't want to have two lowercase h's floating around. All right, so we'll call the function capital H of x is f of x times g of x. Therefore, capital H prime of x is equal to the limit as lowercase h goes to 0. And now when we do the f of x plus h, it's actually every x value gets an x plus h. So it's f of x plus h times g of x plus h, minus the original function, which is f of x times g of x, all over h. And if you're doing this for the first time, if I, on a homework assignment, said, hey, prove this, this might be where you get stuck. Because the next step is a little bit of a trick, right? We've done lots of tricks kind of like this before, where we multiply by 1, where it's kind of a weird looking one, right? The numerator and denominator are the same thing, so that therefore we're multiplying by 1, but they're kind of something strange. We did that when we did conjugates, right, for square roots. In this case, we're going to add something and subtract the exact same thing. And if you add and subtract the exact same thing, those two things would cancel out. We're not going to cancel them, but we're not changing the problem because we're adding and subtracting the same thing. In this case, this is equal to the limit as h goes to 0 of f of x plus h, g of x plus h, minus, we're going to subtract first, minus f of x times g of x plus h. This term, and you might not have, came up with that on your own. Then we're going to add the exact same term, f of x times g of x plus h. So I haven't changed anything. I've subtracted f of x times g of x plus h, and I've added f of x times g of x plus h. Those could cancel out, but don't. And then minus your f of x, g of x, which we already had. So that numerator is the same numerator as before, right, but with an addition and subtraction of the same value, divided by h. This allows me to, I have now 4 functions, and I'm going to look at the first 2 functions together and the second 2 functions together. Or maybe a better term would be terms. I have 4 terms in my numerator. My first term, f of x plus h, g of x plus h. My second term, f of x, g of x plus h. All right, 4 terms. And I'm going to look at the first 2 terms together and the second 2 terms together. And I'm going to take a look at those first 2 terms in the numerator and factor out what they have in common. Well, what they have in common is they both have a g of x plus h. So I'm going to pull a g of x plus h out of those first 2. So I have the limit as h goes to 0. I'm going to factor out a g of x plus h from the first 2 terms. The first term still has an f of x plus h. The second term still has an f of x. Then I'm going to look at, so I have a plus sign here, plus the third and fourth term, and see what do they have in common. We see that the third and fourth term both have an f of x in common. So we're going to factor out an f of x from terms 3 and 4. Term 3 still has a g of x plus h left, and term 4 a minus g of x. This whole thing over h. And then we're going to think of this as 2 fractions that have been added together. We have this first fraction, g of x plus h times f of x plus h minus f of x. Think about that being over h, plus the second fraction being over h. If I were to add those together, that denominator h just becomes, just h. It stays h when you add 2 fractions, right? 3 over 2 plus 5 over 2 is 8 over 2, right? The denominator stays the same. We're going to separate them into their 2 fractions. So we have the limit as h goes to 0 of g of x plus h times f of x plus h minus f of x over h plus, now we'll do f of x plus, just f of x times g of x plus h minus g of x over this h. Right, if I were to add those two fractions, I would combine them and get the common denominator of h. Well, now we'll use properties of limits to have multiple limits here. We're going to look at this as the limit as h goes to 0 of g of x plus h times f of x plus h minus f of x over h, and then plus have a limit over here as well. The limit as h goes to 0, f of x, g of x plus h minus g of x over h. And then we have, in the numerator of each of those limits, we have two functions multiplied. We have the g of x plus h times the f of x plus h minus f of x. So we're going to separate that and look at this as the limit as h goes to 0 of g of x plus h times the limit as h goes to 0 of f of x plus h minus f of x over h. And maybe you were getting to a point, and maybe you got a little bit above, where you can start to see some patterns, some familiarity here. All right, so now it's plus the limit as h goes to 0. We'll just have the f of x times the limit as h goes to 0 of g of x plus h minus g of x over h. All right, we have four limits. I have a function g of x plus h. If h goes to 0, that leaves me with just g of x. Right, as h goes to 0, g of x plus h goes to g of x. Times, by definition, what is this in green? The limit as h goes to 0 of f of x plus h minus f of x over h is, by definition, the derivative of f prime of x. Then plus, the limit as h goes to 0 of f of x, well, that doesn't even have an h in it, so it is just f of x, times, and again, in green, the limit as h goes to 0 of g of x plus h minus g of x over h is, by definition, the derivative of g of x, g prime of x. And if you want to switch the order, this is f prime of x, g of x, plus f of x, g prime of x, and we have proven this. Okay, so we've proven the product rule. Let's use the product rule. And like I mentioned, we're going to use the product rule a lot. The problem right now that I have is we only have a few things we know how to take the derivative of, right? Like polynomial type things, like x squared, power rules, or constants, or e to the x. That is the limit of what we know. So the examples I'm going to do now, some of them are pretty good examples, but some of them are like, I could have figured that out a different way. And that's okay. It's good practice for the product rule, and we'll need the product rule more later on when we have derivatives of other functions, like trig functions, right, that we'll put into play. All right, so first of all, I have three examples. Example one. It was the function that I gave you at the very beginning. What if we had a function such as h of x is equal to 3x squared times e to the x? All right, let's look at this function right here. H of x is equal to 3x squared times e to the x. Okay, now I have f of x, same thing, 3x squared times e to the x. Remember, this is not equal to, please don't do this, this is not equal to 6x e to the x. You cannot simply take the derivative of the 3x squared and the derivative of e to the x and multiply them together. It's not, don't do that. Instead, what we think of is this. The 3x squared, we're going to think of that as like my first function, f. The e to the x, thinking about that as my second function, g. Those are multiplied together. I've already used f. I have to change one of those f's. Sorry about this. Let's go ahead and make that h. So h prime of x is equal to, by the product rule, the derivative of the first function. So the derivative of my f function, 3x squared, its derivative, bring the 2 down, times 3 is 6, x to the first power. That's f prime. And what we want to do is take f prime and multiply it by the original function g, which is simply e to the x. Then plus, right, that's that. Then plus, we want the original function f times the g prime. That's our product rule. The original function f is 3x squared. The derivative of e to the x, this one's, interesting. The derivative of e to the x is e to the x. And so I get this as my answer. I get 6x e to the x plus 3x squared e to the x. And sometimes, this is a fine answer, by the way. I like this answer. But sometimes we want to pull out what you have in common. So you may at times want to do this. Well, they both have a 6 and 3, both divide by 3. I have an x and x squared. They can pull out an x. And they both have an e to the x in them. I can factor all that they have in common. That leaves me with just a 2 in the first term and plus x for the second term. So either one of these are good answers. The reason the second answer might be more beneficial later on is it helps us solve for x. Like if I were to set this equal to 0, for example, the second one might be easier to solve for x in that form. Okay, good. Let's try another. Let's try h of x, number 2 here. H of x is equal to x squared times the square root of x. Now again, this is one where I would not use the product rule here, right? If you gave me this problem, I would think of this like x squared times x to the 1/2, which I hope you do either way. But when you're multiplying, you can add the exponents. So 2 plus 1/2 is like 5/2, right? 2 1/2, 5/2. And then I would just take the derivative from there. We know that h prime of x then is 5/2 x to the subtract 1, 3/2, we're done. That's how I would actually solve this problem. But since we're practicing the product rule and I don't have a lot of options of things to give you, let's instead think of this as 2 functions, and hopefully we'll come up with the right answer still. My first function x squared, my second function square root of x. Or let me go to the second term over here. My first function f is x squared, my second function g is x to the 1/2. We'll use that one since we have that rational exponent. So we can see that h prime of x, and again, pause the video, try it out yourself first, is equal to the derivative of f times g plus f times g prime. The more you write that down, the easier it is to remember it. As you're learning, I would write that formula down every time. All right, so that's f prime, my first function, x squared. The derivative would be 2x, and I'm going to leave g alone. So g is going to stay x to the 1/2. Plus, I'm going to leave f alone, so that's x squared. Then I'm going to take the derivative of g, x to the 1/2. Its derivative is 1/2 x to the subtract 1 from the exponent, negative 1/2. And if I simplify, I get 2x to the, I have an exponent of 1 on that first x, so 1 plus 1/2 is 1.5 or 3/2, plus 1/2 x to the 2 minus 1/2, that would also be 3/2. And if I add that together, 2 plus 1/2 is 5/2, x to the 3/2. I really do get the same thing using the product rule. Okay, last one. Number 3, h of x is equal to x squared plus x times 3x minus 4. Once again, I would not, in general, use the product rule for this, because instead I would just multiply it out. I would instead, if I were just asked to do this problem, I would distribute. I'd say, okay, well, that's 3x cubed plus 3x squared minus 4x squared minus 4x. Combine my like terms, so that's 3x cubed minus x squared minus 4x. And then I would take the derivative. Okay, well, h prime of x is equal to 9, not 27. 3 times 3, 9. 9x squared minus 2x minus 4, done. That's how I'm solving the problem if I get my choice. But since we're practicing the product rule, Let's go and consider the first parentheses here my f function, the second parentheses the g function. So we would say that h prime of x is equal to f prime of x times g of x plus f of x times g prime of x. Or if you want, just f prime g plus fg prime. Right? If you want to kind of assume we're talking about all using x's here as the variable, you can think about this as f prime g plus fg prime. Sometimes that's in your brain easier to remember. So it's the derivative of the first times the second plus the first times the derivative of the second. So we have is equal to the derivative of the first. Our first is x squared plus x. Its derivative would be 2x plus 1. So we have in parentheses 2x plus 1. Make sure you keep the parentheses. Times the g. The g was 3x minus 4, so we will keep 3x minus 4. Plus. We will leave the original f function, which was x squared plus x, times the derivative of the g function. Right, leave the f, it's x squared plus x. The g is 3x minus 4. Its derivative would just be 3. And then if we distribute here, right, so that's the derivative, but that's not very simplified. Let's distribute the terms. So 3x times 2x is 6x squared. 3x times 1 is 3x. 2x times negative 4 is negative 8x, and 1 times negative 4 is negative 4. On the right-hand side, 3 to both of those terms would be plus 3x squared and plus 3x. If I were to combine all those, I get 6x squared plus 3x squared is 9x squared. 3x minus 8x is negative 5x, plus 3x is minus 2x, and then minus 4. 9x squared minus 2x minus 4. 9x squared minus 2x minus 4. Either way it works. So the product rule, again, does work.